All right, so why do we need quadratic equations and stuff? Well, there are a lot of things that happen in nature that require us to come up with quadratic equations. One of them is gravity. The big thing that I want us to, well, let me go ahead and read. The quadratic models opening upwards, the minimum occurs at the vertex, and downwards, the maximum occurs at the vertex. And the coordinate, the x-coordinate of the vertex is x equals negative b over 2a. That's going to be sort of our theme for all three of our examples today. All right, an object, example one. An object is propelled straight upward from a height of 6 feet with an initial velocity of 32 feet per second. The height at any given time t is given by s of t equals negative 16 t squared. That has to do with the acceleration of gravity. It's because we're in feet per second, and it's negative because gravity is downward. 32 is positive because it's being straight upward. That's why it's a positive 32 at a height of 6 feet. So if we're on the ground here and there's a platform at 6 feet, then the object is thrown like this, and here is our vertex, and that'll be the maximum height attained by the object. So in this case, x is t, right? So t is going to be negative b over 2 times a, which is negative 32 over 2 times negative 16, which is exactly negative over negative is positive. 32 over 32 is 1 second. So after the person throws the object, after 1 second, it hits its maximum height. What is that maximum height? Well, let's find out. That's s of 1. It's going to negative 16 times 1 squared plus 32 times 1 plus 6. So negative 16 plus 32 plus 6 is, let's see what that is. Negative 16 plus 32 plus 6, 22. So at this maximum height here, after 1 second, the object is 22 feet in the air, which makes sense. We started at 6 feet, threw it up pretty hard, pretty fast, 32 feet per second, and it maxed out at 22 feet. All right, example 2, a rancher has 200 feet of fencing. That's going to be the total perimeter to enclose 2 adjacent rectangular corrals. What dimensions will produce a maximum enclosed area? So here's what we're looking at. So if I call this x feet, this is also x feet. Now here's where it gets a little tricky. What is this height here? Well, all of it, including the endpoints and the middle fence, that's also part of the 200 feet. It's going to be 200 minus 1, 2, 3, 4 x's. And how many of these are there? 2, 3. So this height is 1/3 because there's 3 of them here. So 200 overall, including the middle, minus 4x, because we're just looking for this height here. And because there's 3 of these, I have to divide it by 3. So that's what that is. An area, of course, is, and I'm just going to find the area of one of the corrals here. So that's going to be x times 200 minus 4x divided by 3. And we can rewrite that as negative 4/3 x squared plus 200 over 3x. So again, this is the area of just one of the enclosures, which is fine. And so we'll find the dimensions of just one of the enclosures. So in this case, our maximum x is going to be negative b over 2a. So that's going to be negative 200 over 3 divided by 2 times a, which is negative 4/3. So I'm going to get rid of the negative. Negative divided by negative is going to be positive. That's fine. So 200 thirds over 8 thirds gives me 200 over 8, which I believe is 25. 200 divided by 8, 25 feet. 25 feet is one of the dimensions of one of the corrals. Now, if I want to find the other dimension, I'm going to have to plug it into here. So this is 200 minus 4 times 25 divided by 3. That is 200 minus 100 over 3 is 100 thirds feet. So here are the two dimensions for one of the corrals. But if I want for both of the corrals, that would be 50 by that. All right. A revenue function for a new plasma television is given by R of P equals 900P minus 0.1P squared. What price P, so the P is the price, should be charged to maximize revenue? And then what is the maximum revenue? Okay, so P is our new X. So P equals now. So P, now it's a little confusing because that is my A and that is my B, right? A is always the one with the squared part. So negative B, which is 900, over 2 times A, which is negative 0.1. So that's going to be a negative divided by a negative. That's fine. And let's throw this into here. 900 divided by 2 times 0.1. $4,500. $4,000. What was it? $500. $500. And what is the maximum revenue? Well, I'm just going to take, so this is one of the first answer of the two. To answer the second question, what is the maximum revenue? I'm going to plug that into here. So R of 4,500 is going to equal 900 times 4,500 minus 0.1 times 4,500 squared. So, and I'm going to do this all as one line with my calculator. A different calculator may require you to use more parentheses and things like that. So please make sure that you practice. Ooh, so the max revenue, that is not too shabby there, is $2,025,000. Ooh. You can see why this is good for businesses to know things like this if you want to maximize your profits, of course. Hope that helps.